Okay, so whenever you're asked if a number is a solution to an equation, you should plug it in and see if the left side equals the right side. We know this, right? But when it's imaginary, it's more challenging because you have all this other stuff to deal with, like 5 plus 2i squared. What do I do with that? What do I do with 5 plus 2i squared? What should I do? How do I square that? What do you guys think? You can't do it separately, though, because there's two things inside. Remember, if two things inside, yeah, you got a FOIL, right? And that's kind of a pain. I'm going to distribute the 10 while I'm at it. So I get this. Okay, let's do it. Before you get 25 plus 10i plus 10i plus 4i squared. Be careful, there's a lot of negatives going on here. Negative 50, negative 20i. And I'm really running out of space here. Equals negative 29. Okay, now you got to clean it up. So what happens when I clean it up? You get 25. What's 10i plus 10i? No, 10i plus 10i. 20i. Mm-hmm. So you're like variable. What's 4i squared? Negative 4, right? Because I squared is negative 1. We know this. Negative 50, negative 20i. Okay, now I can really combine like terms, right? If I think about it, 25 minus 4 and then minus 50. So we'll take 4 away from 25, and 20 minus 50 should be negative 29. What happens to the i's here? Cancel. Okay, so it works. Okay. It's quite a bit of work, right? Here, I feels a better way. This is my way. So if you think about it, right? If I give you an equation, don't copy this down, just say, if I give you an equation, ultimately you get down to this, right? X equaling something, and X equals something else, right? What if I work backwards? So you know X equals 5 plus 2i, right? You know this. By the way, if it equals 5 plus 2i, it also equals 5 minus 2i. Why? Because are there any i's in the equation? No, not at all. So they always come in pairs, just so you know. So if you have like 5 plus 2i, you need 5 minus 2i as an answer as well. We're going to talk about that in the next unit, but just want to let you know that. So what should I do if I want to get the equation? What if I move that 5 over to the other side, right? Wouldn't that have been the previous step, right? Because I had to move the 5 from earlier. What if I square both sides now? If you do it, what happens? I get x squared minus 10x plus 25 when I FOIL. And what's 2i squared? Actually, negative 4. Because you square the 2 and you square the I. And the plus minus just goes away. And guess what you get? Do you get the equation that we have originally? You do. You get the same thing. That's a much cleaner way to get the equation from imaginary solutions. So that's something that we'll talk about, I think today or the next unit. I can't remember. I have to look. But really want to make sure you guys are present to that. Like that's a much better way to doing that as opposed to just plugging. Because plugging in, which one looks cleaner, the red or blue? There we go. Which one's gonna be easy for me to grade? Probably the blue. You could do it the red way if you want, but you're more prone to making an error. So just want to help you guys out. So just keep that in mind. I'll do a screenshot of this also. So here we go. Okay, so anything else from the homework you guys want to talk about before we move on to the lesson? No? Okay, let's move on to the lesson. Here we go. All right, so let's talk about the last topic. What are complex roots? Which is kind of what we just talked about right now. So what you want to do is you want to set y equals 0 and solve. That's it. I'll do part A. I'll have you guys do part B. All right, I'll walk around and help you guys out. Let's look at part A. Let me zoom in again. Yeah, that's fine. All right, replace y with 0. Here we go. Okay, your goal is to get x by itself. What should I do to get x by itself? Great, awesome. Okay, what's going on with x? It's being added by 5 and it's being squared. Root, thank you, Lincoln. So you root it. I'll do it in red so it stands out. Now, whenever you solve by rooting, you got to put plus or minus. So plus or minus 3i. You have to put plus or minus. And I, because of the negative, equals x plus 5. Now we're almost home free. What's the last step?
-5.
Move the 5 over. Good. So x equals, I don't have round space here. And those that come in pairs. -5 plus 3i, -5 minus 3i. If I were to do quad form, if I were to expand x plus 5 first, you could expand it and do quad form. You get two answers too. We know this, right? Because quad form has plus or minus built into it. Does that make sense? Okay, go and try part B. I will do it on my end over here. I'll freeze the screen. I'll give you guys like a minute or two. It shouldn't take very long. We'll check in just one moment. You're gonna probably want to do quad form, by the way, for this one. So you're gonna want to do quad form. Because it's already in standard form. You could do completing the square, but I don't know if you guys remember that. And please simplify it afterwards too, if you can. Jeez, I forgot what that's gonna be. 2, 5 root 5 over 2. Okay, anyone have an answer you want to share? No? Anyone have an answer they want to share?
Not the code.
All right. So let's talk about when you
Not
subtract
subtract, but when you divide by two.
at the end.
At the very, very.
At the very end, yes. So think about it. -b plus or minus square root b square minus 4c all over 2a. That's it really fast. Your b is -4. What's negative of a negative? Positive, right? We know this. Square root -416. Minus 4ac, which is 36, because a and c are 1 and 9 respectively. 60 minus 36, -20. Great. But it's negative, right? So you have to have an eye. This is the other thing too that maybe we haven't spent enough time on. Simplifying radicals. What factor of 20 is a perfect square? Oh, great. Pull it out. Maybe pull it out. Wasn't count. 2. Well, it stay inside. 5, right? So we need to be present to that. Root 4, root 5 is 2 root 5, right? But there's an I. And then to answer your question, I want at the very end you divide. And by the way, you cannot divide the 4 by 2 and not divide by the other one as well. You have to divide by both because of plus minus. So you got to divide or pull out the 2 and in fact cross it out. But regardless, you get 2 plus minus I root 5. So now, if we think about both answers had imaginary numbers, right? How many x-intercepts would both these equations have? Would it have any?
No.
0, exactly. Neither equation across the x-axis. Because think about it. If I were to graph, you don't have to draw this, but if you were to graph A, do you guys know what the vertex is for A? If you look at the vertex form?
Yeah.
Yeah, good. Awesome. Good. -5, 9, right? So it's right here. And then because the leading coefficient is positive, is open up or down? Up, right? It's not touching the x-axis. Look at B. That's standard form. We talked about the advantage between these two forms. The advantage of standard form is I can get the y-intercept easily. If I plug in 0 into that equation, what's y gonna equal? What's the y-intercept for part B? 9. Good. Yes. Now the vertex I don't know, but if I do -b over 2a, -4 over 2 times 1, I get 2. But plugging 2 back in the equation, I think it's a positive y-coordinate for the vertex. I think the graph will look like this. Again, won't touch the x-axis. But you should check the vertex to be sure it's above, not below the x-axis. And we know it opens up because your leading coefficient is positive. So we're starting to really make these graphical algebraic connections, right? So let's look at 880. Actually, I'll give my voice a little bit of break. It's more, it's just kidding because your voice is gone. I'm teasing you. Eloise, can you read 880, please? Mhm. So thank you. I already kind of talked about what we see. You see plus or minus each time. They have to come in pairs. They have to come in pairs because your original equation didn't have I in it. If all the coefficients are real in the equation, then the imaginary solutions must come in pairs. And we call it the conjugate. So they have to come in pairs. And actually, you know what? This is great because we're going to have a Jeopardy game on this very, very soon. This is great. So I'll do the first couple. I'll have you guys try C and D. If you add them up, simple, right? You get 4. That's easy, right? What happens to the i's to go away? How about part B? If I add them up, what do I get? 6. Awesome. Good. Now, if you FOIL, that takes a little bit of work. It will come out as a real number. Remember FOIL, first, outside, inside, last. First, outside, inside, last. FOIL, right? So you get 4 plus 2i minus 2i and minus I squared. Be very careful. What happens to the 2 i's? What's I squared? -1, but it's a minus and negative. So it becomes 5. If I do likewise for part B, 3 minus 5i, 3 plus 5i, that'll be 9 minus 15 plus 15. Notice the i's cancel again. They should. That's the intention, right? Minus 25i squared. We have a minus and negative. So it actually comes plus 25. So you get 34. Okay. Go and try C and D on your own. I'll work it out. We'll check in about a minute. Right? Go and try C and D. Okay. I think I got it. Okay, what do you guys get for C? And okay, take your time. If you multiply it out, what's -4 times -4, guys? -4 times -4, 16. And how about negative I and I? Negative I squared, which is 1. Good. So you get 17. Correct. -8 and 17. And part D will be 2 and 4, because if you do √3 times √3 is 3, but negative I squared √9. So you have 1 minus I squared times 3, which should be 1 plus 3. So you have 4 when you multiply it out. So all should come out as a nice clean number. And we call these.
What is the common, like, mean?
Oh, just the second part. That's all. The sum and the product. -1. -1. So 1 minus -1, but you're doing -1 times 3 first, which is -3, and 1 minus -3. So I skipped a couple steps.
I get the addition. I don't get how to find the sum.
Oh, you just add combine like terms. 1 plus 1 is 2, and the I √3, negative I √3 cancel. Yeah, so yeah, Evelyn, sorry, kind of did that kind of fast. So you get this. Yeah, so that's what's happening. You guys tabulating the points of who's.
Yeah.
Okay. It is a math. It's a pretty good math problem. I don't know how they do the points these days. Yeah.
We've won the most events by the mark.
Okay. You guys are well. Just keep it going. Well, now I really want to go to the closing ceremony tomorrow. It's good.
Mr. East definitely a secret judge. He's gonna be outraged.
I am a secret judge. I am a secret judge. Yeah.
Senior.
Okay. Okay. Okay, guys. Hey, whoa, Spirit. Well, they're sophomore, so. Yeah, you can't win anyway. So okay.
Oh, yeah, no, I don't think we're.
Yeah, you can talk much crap if you want. All right. The juniors have to. All right, guys. Keep moving, guys. All right. C was 16 and -8 and 17.
Other girl like.
Yeah. Okay. Well, okay, guys, let's get back. You guys are doing great. Let's keep moving here. Okay. Let's not waste time. All right. So for part E, actually, I'll give my voice another break. Jasmine, can you read parts E, F, and G, please? You just run the bus. Okay, keep going. Read F and G also. So if you want, okay, and Aiden, can you just be really quiet about that? Thanks. All right. So if you think about it, if you switch a sign in the middle, that's going to get you the real number. So we call this the conjugate. There's a term for this. It's called the conjugate. For those who've taken chemistry, have you guys learned about conjugate acids and bases? It's kind of like the opposite. That's what conjugate means. I'm not sure if you guys have done that in chemistry. For part G, I'll do G before F. Again, you want to do A minus BI. So you always want to do the opposite. Again, we call this the conjugate.
Wait, why? What does that do?
Because the I's will
Oh, that
cancel.
cancels out.
It cancels out the I's. For F, what will happen, I'm not going to do it, but the I's won't cancel. Let me change colors for a bit of contrast.
Oh,
Mhm.
like, why can't you like sub in -1 for I and then multiply the
It's actually root -1, not -1 itself. It's a square root. So we have to multiply I by itself to make it -1. So that's why I'm introducing another I. That's the opposite in sign. Instead of positive 2I for parts, root -1. It's a square root. Right. So for part F, the I's won't cancel. That's what will happen. So that's exactly what I said down below. Complex conjugates. Okay. So the sum and product are always real numbers, just so you know. Always real numbers. Okay. So let's move on to 886. For each pair, find a quadratic equation. Okay, so I'll do A and C. I'm gonna have you guys do B and D. So here's what you want to do. So today's Jeopardy, there's two categories. One category is factoring and giving me the roots. The other category is like this. So I deliberately made the game today to help you with what we're doing today. Where I'm gonna give you the roots, you gotta give me the equation. So here we do. So here we go. Here's how we do it. Think about it. That's gonna be x minus 3/4. And that's going to be x plus 5 equals y. If you want, I am going to ask this in standard form. So you're going to want to FOIL afterwards, right? You're going to want to FOIL it. But before I even do that, I could rewrite this as 4x minus 3.
Mr. Reed, what are complex conjugates?
They're basically the numbers that are the same, but the sign in the middle changes.
Okay.
It's a complex number, a plus bi. So remember we talked, actually, let me make sure we're clear on this. A complex number, guys, is a plus bi, where it's a real number plus an imaginary number. But the conjugate is just you switch a sign in the middle. That's all it is.
So complex conjugates are just like two conjugates.
Right, correct. Right, correct. You could do it also for radicals too. So, do you guys see I got 4x minus 3? Okay, guys, focus. Do you guys see I got 4x minus 3? Okay, I multiply this by 4. Because that gets rid of the fraction. So you could do that. This just changes the leading term. If you FOIL it, you should get 4x squared minus 3x minus 3x plus 20x.
But now, can you just multiply like one like parenthesis?
You can, because technically there's actually 0 on the other side. That's
But
that's
doesn't it also have to multiply to the x plus 5?
no, because I just did it to the left side because it's all multiplication. Technically there should be a 0 there. So it's 4x squared plus 17x minus 15 equals 0. Okay, for part C, and I'm going to have you guys do B and D in a moment. Remember I told you my special way? This is my way. I like it better than other ways. So remember, we do x minus 5 equals plus minus 2i. You square both sides. You get x squared minus 10x plus 25 equals -4. You guys want to check your math to make sure you're winning?
Yeah.
Okay.
We should do our calculation. Yeah.
All right.
Maybe calculus was.
No, that's simple math. It's actually a spreadsheet that you punch it in. I was a judge about 11 years ago. I don't know. Look, but it's changed. But Monty wasn't here then, so it's changed. So I don't know. So you get that. Okay, go and try B and D, guys. All right, guys, let's focus B and D. All right, let's do B and D, and then we'll talk about discriminant. Then we'll play Jeopardy after that. I'm going to do it also. We'll compare in just a moment. And guys, start like this. Start like that. Okay. I know. It's silly. I know. There's something that if I see you guys at a reunion about 10 years from now, I was like, remember in math class you were doing this calculation and
Yeah.
and you guys actually didn't win. It didn't matter.
We're gonna win. We won 6.
Actually, when I do see the class of 2010, I do say, do you guys still care? They kind of care a little bit.
Won 6.
Actually, Miss
Did they win?
no 2010 lost. Yeah. So Miss Freeze in the English department, she was a part of that class. Yeah. I think you should ask her about it.
Won 3-point boys.
She was a losing class. Yeah. And actually, Mr. Hunter and I were their class moderator for 3 years. So
Whoa.
they didn't quite have the best spirit at times.
Wait,
No, they won knockdown.
we haven't won in a long.
What? They actually have it?
No, of course having won. Yeah, had won it. We've won everything.
Okay, guys, let's focus. Let's do some work, please. Thank you. No, I was making a comment. So- all right, so move, square both sides. Okay. But for the second equation, move the 3 over first. So move that -3 over from right to left and then square both sides. And your goal is to get 0 on the right side. Your goal is to get 0 on the right side. To get the equation that is generated.
Plus minus 3i squared. Is negative.
Because when you square I, you get -1. The plus minus goes away when you square. Because regardless if you square a positive or negative, that just goes away. That won't matter.
And so. It's the indicator of like when you just separate them equal to x,
What was that?
like when you just set one side equal to x, like how do you know what you're supposed to do?
Oh, because these are the solutions. So you're working backwards.
But the first.
You're trying to get the
one-
equation it comes from.
The first one you just like multiply. Just like back, or you did FOIL.
I didn't have to because it was just one term. It was plus minus 3i. I didn't have to. So you guys should get this. You should get x squared plus 9 equals 0. And you should get x squared plus 6x plus 9 equals 2. We move the 3 over, -3 over. Then bring the 2 over, you should get that. And if you did quad form, this would confirm. If you did quad form or solve for x, so you're just going backwards. That's what we're doing. We're doing the reverse. Okay. Let's talk about the discriminants. Not sure if you guys know this. Actually, don't have to write this down. If you guys could just watch for a moment. So can someone recite quad form for me again? Negative b plus or minus what? B's. Well, two ends on the bottom. Good. Okay. So we're only going to focus on this part here. Okay. Now this is a bit of a play on words. B squared minus 4ac. This is called. Okay. So guys, focus. So discriminant. What does that sound like to you? So forget about math class.
Discrimination.
Discrimination, perfect. What is discrimination? Yeah, or being feel excluded. But what kind of discrimination can there be, guys? In context, discrimination could be what? Could be racial, gender, socioeconomic, age. We're talking about discrimination. We're talking about because I want to talk about social justice. That's why. What was that? No, it's okay. But let's now bring it back to math. Okay, now we'll bring it back to math. Okay, thanks, Abe. Discrimination means to judge based on differences. In math, it's not as offensive. It's more just, hey, b squared minus 4ac. It's judging based upon the sign of b squared minus 4ac. It's judging how many solutions you'll have. That's why it's called discriminant. It discriminates. If you have discriminating taste, that means you can judge things really well. Like if you can, like, for example, I have discriminating taste with iced tea. The Starbucks iced tea is better than this one. But anyway, that's just me. I could judge. I could judge, right? So that's what's happening. You're judging. So let's copy this down now. If b squared minus 4ac equals 0, you have one real solution. This is really important because this is a big part of our test in 2 weeks. If it's positive, you have two real solutions. And if it's less than 0, you have two imaginary solutions. So it plays a key role in also determining the x-intercepts. So I'm going to do a little slash here for each of these. So you understand graphically what's happening. One x-intercept, two x-intercepts, and no x-intercepts. That's an algebraic graphical connection. So b squared minus 4ac, the party at the radical. If that's negative, forget about it. No x-intercepts, two imaginary solutions, because you're going to have I. If it is greater than 0, great, two real solutions. Even though they might be nasty, that's what it is. If it's 0, it goes away. You're stuck with negative b over 2a. That's actually the vertex, by the way. That's going to get you with one answer. And of course, we'll review all this stuff when we're back from break. So we're all at the home stretch here. You guys are doing great. So how many real roots does this have? Well, obviously this has 2, right? And obviously this has 3. That's pretty obvious, right? This has none. And this has 1. So what this means is that there's 2 real and no imaginary. This is 3 real and no imaginary. This is none. That's 2 imaginary. That's 1 real, 2 imaginary. So that's what's happening there. Because your number, and this is the key, guys, quiet, please. This is the key idea. The key idea is that the degree will equal the number of real plus imaginary roots. That's actually called, and it sounds kind of weird because you guys have done algebra for quite some time. It's called the fundamental theorem of algebra.
That was an answer.
It was, okay.
I'm like a freshman dog.
Yeah. What was it?
Oh, I heard I was in the quiz bowl too. I didn't show up. I know I should have shown. Because I don't get who were the other choices?
Hadn't taught us sports.
Who teaches but not coach, right?
No. Who hasn't been a varsity head coach?
Kevin Morris,
Coach?
Mom.
No.
It was TDEP.
Morris,
TDEP.
you and Deb.
Yeah,
It was Dep and
football. He was the first football coach.
But he was baseball. And then
That I don't know, but he was the first football coach. Swing. He swung for the longest time. Yeah. And then Mr. Moffat coached Yeah, he coached girls soccer when we had Abby Dahlkemper, and he's not the head coach though. It's Armando. But yeah, we had Abby Dahlkemper and Tierna Davidson. He was the head coach. Actually, not sure with Tierna, but I know with Abby Dahlkemper he was. So okay. I can do sports analysis though. I could be a GM. Like that. So I could be a GM. Like Andrew Luck of Stanford. And we need NIL. Yeah. Okay. And recruit like kids from the middle school. Yeah. All right, last part, guys. We're almost done here. We'll play Jeopardy after this. Okay, so guys, quiet. So recall that a degree n crosses x the most n times. So the graph of a third degree might intersect x 1, 2, or 3 times. Make a possible sketch of each. So it looks like this, right? If it does 1 time, you have to have that.
Can you just have a linear equation?
No, we're doing degree 3. So once, twice, 3 times. Now, this is the big question here. Can this have no x-intercepts at degree 3? No, why not? Think about the arrows. That's true too. Arrows are in opposite directions. And as we said, Lincoln, a continuous graph. So it's got to touch eventually. Now, if the arrows are in the same direction, then you can miss it. But yeah, the answer is no. That's the reason why. Okay. Good. Okay, we did great. Awesome. I feel good. We will review this. I will get you guys the review packets while we're playing Jeopardy. While you guys are mulling over. Yeah, so we're just gonna do this. We'll do that's fine. Yeah, hold on. Okay, I assume
I have to do
okay, so Samar, why don't you join Karen and Eloise? Char okay, we'll do a big team. So Karen and Eloise, you'll just join. Okay, and then okay, and then
Get 3 hours.
well, oh that's the blinds, yeah. Hold on. Because I don't want these teams to be too big though.
Dude, wow. Team.
Hold on.
Me and Tao can honestly just be a duo.
Okay, so we'll do this. Hold on. I'm just trying to think what's fair. All right, hold on. Because I'm doing this for extra credit too. I don't want I want like people actually participate. I don't want like 7 people on a team. That's too much. Yeah, let's do teams of 3. So Reggie and John, I'll have to separate you guys. Do you want or Eloise and Lois? So you could. I'm sorry, Alexandra and Lois. You guys can. Or you guys. Hold on. I'm just trying to think. What would be fair? Hold on. 16. No, I'm just trying to think here. 4. Yeah, hold on. We got 17 people, but Evan's not going to participate. Oh, sorry. Okay. Let's do this. No, I'm gonna break up the teams. Okay, so so Sophia, I'm gonna have you join Eloise and Karen. Okay. And Reggie, I'm gonna have you join also them as well. Eloise, Sophia, and Karen.
Wow.
Okay, then Adelaide, you'll join Aiden, Nathan, and Charlotte. And it will be Lincoln, John, Lois, and Alexander will be a team. Yes. Why?
He gets everything right. He writes it down, and then it's correct.
No, well, you're capable of getting things correct. You can totally do it. Yeah, so that's how we're gonna do teams, okay? All right, so I think we are Good. Okay, let's do this. Here we go. Let's get started. As usual, we'll do X credit. All right. So slideshow. Hold on. All right. So finding zeros is just factoring and giving the x-intercepts. Writing the equation, I'll give you the x-intercepts or the roots if they're imaginary, and give me the equation that goes with it. Mysteries, personal questions about me. Okay. So let's
start with Mr. 1000.
don't blur out the answers, you guys know how this works.
I'm listening, I'm sorry. I'm just strong.
Yes, yes.
Yeah, nothing. Why is that your auto? Because there was an email. Or no, it was.
If I saw you,
It was
All right. So I'll get started with the first question, and then whoever gets right first controls the board. Don't blurt out answers. Call me over. Guys, you have the boards to use. You got paper. Here we go. Okay, give me the roots, guys. Give me the roots. So start that easy. Give me the roots. So it's also factoring, or you plot form. I don't care. Hey guys, let's focus. You guys want points?
Yeah.
Do this. No. Everyone gets a point. Whoever gets right first. But remember, it's every $1,000 is 1 point.
It's factoring.
Yeah. You want to get 0 on the right side and factor afterwards. Okay. John, can you help the team out? Do some work, man. Get some paper. You can't do it sitting on Lincoln's lap. Look him over. No, once the roots.
He has a good.
Yes. I actually want to confer over repeating. All right. So 2 groups already got it.
Wait, I got it. Can't you just?
Oh, so sorry.
Mr. Yeah,
No, don't do that. No, you for factory. It's actually factory. Good. Yeah.
Thank you.
I didn't even see
Thank
this.
you, Alex.
Okay, then we'll go to the next answer for the solutions.
Thank you, Alex.
All right, everyone got it. Okay, good work. Everyone's on the board. Now, or you can factor it. These are factorable. Okay, so Jasmine, Sarah, Allison, and some more. You guys are control the board. What do you guys want? And actually, I don't need a course anymore.